Okay, so I've loaded up an example, and here we go. I've got data with blood alcohol content related to the number of beers consumed. So we've got data from 16 student volunteers at Ohio State University, and they each drank a randomly assigned number of cans of beer. And so over here, some individuals consumed 5 beers, 6 beers, 2 beers, 1 beer. And then the blood alcohol content was measured for each of those individuals. And they had men and women in their group. They kind of differed in their drinking habits and weight. And it looks like a police officer measured their blood alcohol content. So it was kind of in a controlled environment. So what we're going to do is I want to show you how to draw a scatter plot in Google Sheets, and we will use Google Sheets to also get the least squares regression line. So there's some problems like this on the homework, and you would just copy paste the data, and I've done that here. And before I get ahead of myself and graphing all sorts of stuff, I want to anticipate our results a little bit. Now, do you think these two variables have a positive or a negative correlation? Or no correlation? Well, we would expect that the more an individual consumes, the higher their blood alcohol content will be, right? So I'm anticipating, just a little note here, a positive correlation. So we should see a positive slope when we draw this line, and we should see a scatter plot that illustrates that. So let's see, how do we draw this line? How do we get the scatter plot in Google Sheets? I like to, sometimes Google's smart enough, but I like to highlight the values. And then when we go to Insert, Chart, it knows which values to refer to. So Insert, Chart. Now it knew I wanted a scatter chart, but sometimes it defaults to something goofy. I don't even know what this will look like. But go check out the chart type, because it could default to something that you don't want. And it might be that a scatter plot is one of the suggested charts, but if it's not, then it's towards the bottom, there is a scatter option. So there's our scatter plot. Doesn't it show a positive correlation? I think so. So how are we going to get the line to this? So I believe if you select Customize, and you can, go investigate some of these options, just see what's there. If you want to put some titles or change your font, there's all sorts of stuff you can do, but I believe it's under Series. And I want it to draw a trend line. Boom, there it is. So it drew the line to it, but it would be really nice for us to know the equation of the line. So what's the slope? What's the intercept? And I think if you keep scrolling, label, use equation. Label the equation. And there it is. Now, it did a little scientific notation here. We'll dissect that. So let's go write that down and analyze this. Before we look at the equation of the line, I just want to write down some notes here so that you know what to do when you go to Google Sheets.
I like to highlight the data, go to Insert, go to Chart, and then go to Chart Type, and make sure it's on Scatter. It might default to that. And then it was under Series, where you select Trend Line, and it will draw the line, and then you want to ask it to label the equation. I think it says Use Equation.
So here's the equation that it wrote in the scatter plot. And we're going to rewrite this so it's in the classic line format and analyze the slope and intercept here. So the y variable was the blood alcohol content, right? And we would be using this line to predict the blood alcohol content. The slope is the number multiplying the x. The intercept does not have an x multiplied on it. I'm going to write the intercept first. You don't have to do that, but let's think about how we write this number. Right, this little e with the -3 business, that says take the decimal and move it 3 places to the left. And there's a negative sign on it, so it's -0.00905. 1, 2, 3, yep. And that's the intercept. And the slope is 0.0182 times x. Let's interpret the value of slope from the least squares regression line here. Our slope was 0.0182. Now, what do I mean by interpret this? Notice it's a positive number. And this is the change in y over the change in x, right? People often say rise over run, but that implies that this is the change. Instead of writing the letter y, I'm going to say blood alcohol content over the change in x. But what was x? The number of beers consumed. Say number of beers. Now let's think about this slope then as 0.0182 over 1. Often when folks say interpret the slope, they want you to consider what is the blood alcohol change for every can of beer consumed. So for every 1 beer consumed, I'm getting that number 1 from down here, we would expect blood alcohol content to go up, right? The more you consume, the more you've consumed. And we would expect the blood alcohol content to increase, because positive correlation, by 0.0182. Moving along here, let's use this line to make a prediction of the blood alcohol content for someone who consumes, oh, pour them 3.5 beers because they spilled half their beer. Well, this line is used to make predictions. What are we going to do with this number 3.5? Well, that is a number of beers amount, right? So we're going to plug that in into x. And when we do that, over here, we'll plug in a number for x, and then we'll calculate y. Here we go. So the predicted y value, the predicted blood alcohol content, we're going to compute -0.00905 plus 0.0182 times 3.5. I'm going to open up my calculator. So I've typed in -0.00905 plus 0.0182 times 3.5. And our blood alcohol content predicted after 3.5 beers, 0.05465. This is the predicted blood alcohol content after 3.5 beers. This is not a piece of data, but this is a point on the line, on the least squares line. That point, right, we plugged in an x value and we got a y value. And if we go look at the scatter plot here, we will see that this is a location on the line. Let's take a look. So if I was to put a tick mark here for 3.5, the y value on the line should just be over 0.05, and that looks about right. I've got another question for you. How many beers would it take to reach a blood alcohol content of 0.1? We're going to use the line to figure that out. Visually, it looks like, all right, blood alcohol content 0.1, that's a little over the legal driving limit. It looks like it would take about 6 beers to get there based on this line. Now that's a visual approximation. It seems pretty reasonable, but let's go use the equation of the line to figure that out. So I rewrote the question here based on the linear model. This is like a model to predict blood alcohol content. But we can go backwards too. How many beers would need to be consumed to achieve a blood alcohol content of 0.1? Here, we will not plug in a number for x. We will not. Because we were solving for x, right? Because the question asks, how many beers does it take? So what we're actually going to plug in is this 0.1, and we're going to plug that into the y value. Once we plug that in, then we'll solve for x. So on the left side of the equation here is going to be the 0.1 equals the intercept 0.00905 plus 0.0182 times x. And now we will solve for x, because that's what the question is asking. How many beers does it take to get to this 0.1 blood alcohol content? I'm going to do a little subtraction here, right? We should subtract, or maybe I should say we should add this 0.00905 to both sides. Let's look at the calculator. 0.1 plus 0.00905, which is about a 0.10. I'm going to write all the decimals. Why would I leave it out? And then on the right side of the equation, we still have this slope times x. We are solving for x. So what should we do to both sides of this equation? We should divide by 0.0182, and then that will get us x all by itself. Let's look at the calculator. I'll take our previous result and divide by 0.0182, and remember what we saw from the graph. Our answer, we thought, should be about a 6, right? We said blood alcohol, 0.10. It looks like it takes about 6 beers to get there. And I think this is going to get us there. Ooh, just shy of 6 beers. So I'm going to write that down, about 5.99 beers, approximately. We can call that 6, right? Cool, so we did a lot here. We had a data set. We used Google Sheets to get the equation of the line. We interpreted that slope and did a little prediction. In the next video, we'll talk about how reliable this prediction is.